All right, for my second point, what do I do with the x value first? Square it. Do you know 14 squared off the top of your head? So can we just put in 14 squared? You okay with that? What do I do with the second value? I just enter the x. What do I put for the third value? 1. Oops. Tab and then 1. And then what's my y value for my second point? 20,600. Whoa, geez Louise. 20,600. My last point, what do I do first? 28 squared, I squared the x value. What do I do next? Just enter the x value. What do I do next? 1, and what do I do last? 1,000. So what does this tell me? What did I just solve for? If I entered the x's, what did I just solve for? A, B, and C. A, B, and C. So if I go to write my equation, I'm going to zoom back out a little, not in, out a little bit. I'm going to say negative 100 x squared, because that's what I got for A, right, the 100, and then plus 2,800 x, and then plus 1,000. Okay, do you remember doing that when we studied quadratics? Okay, so that's one way you can find a quadratic equation. You can use a matrix. Okay, another way we could do this is we're going to add a page that is a listen spreadsheet. We're going to come up here and call this x. We're going to come up here and call this y. And then we're going to look at all our x's. 0, 14, and 28. And then we're going to look at all our y's. Whoops, not there. 1,000, 20,600, and 1,000. Thank you very much. I caught it, but I was just going to go back to it, but thank you for helping. Okay? Remember, make sure you have to enter after this last one, right? You don't want to leave your cursor right there. You want to enter and put this down here. Yeah? Now let's add another page. That is a data and statistics page. We want to, where's my cursor? Oh, escape. I want to come down here. I'm going to call this what? What am I going to call this? X. That's my x-axis, right? I'm going to come over here and call this Y. And now I need to do menu, analyze. What? What am I choosing? Yeah, regression, right? What type of regression am I choosing? Definitely quadratic, right? That's what we know we're trying to find. Boom, there's the equation. Isn't that the one I just got with the matrix? Yeah? Your choice the way you do it, unless the directions say to do it specifically in one way or the other. Yes? Okay, any questions so far? Okay, now, what it asks us to do next here, still on question number 2, is check the equations using a GraphQL calculator with this domain. Okay, so I need to add a page that is a graph. And I need to enter each one of these. 1,000 plus 750x. Tab 1,000 times 1 plus 0.12 raised to the x. And then tab negative 100 x squared plus 2,800 x plus 1,000. Now, to me, these two graphs don't look anything alike, right? But then I look at my directions again, and my directions say, check it with a graphing calculator using this domain, 0 to 28, right? So I need to change my domain, change my window. So I'm going to say menu, window, and I'm going to adjust my window settings. Now, what did it ask me to use? 0 to 28 for x's, right? So 0 to 28. What about my y's? It doesn't tell me what to use for y's, so could I use some context clues about what to use for y's? What should I use here? 0 to, how about 25,000? Would that be okay? Because that's 10,000, that's 20,000. Would 25,000 make sense? Okay. Now, how do they look? Are they similar enough? Yeah? Okay. Problem number 3. Use the functions to complete the table. Do I really want to plug all these numbers into every one of these equations? What could I do instead? Can't I use the table? Right? So first here I'm looking at the 100 plus 75x, so that's Alan, right? So I'm going to put his numbers in this first column, yes? Right here. So after 5 years, let me scoot down. After 5 years, Alan has $4,750. That's good, right? After 10 years, whoa, $8,500. Excellent job, Alan. After 20 years, $16,000. And after 25 years, $19,750. Now, since I'm already down here at 25, can I just right arrow over to look at Bernice's numbers? Okay. So how much does Bernice have after 25 years then? And 6 cents. I can look right here to see it for sure, right? Okay. And then I'm going to go up to 20. So 9,646 and 29 cents. And then scoot to 10. 3,105 and 85. Do you see that should be 85 cents? And then down to 5, $1,762.34. Okay, for Bernice? Right, now Carl, yes? Okay, I'm going to arrow over to the right to get up to the right equation, make sure I'm on the right equation here. So for 5, after 5 years, Carl had $12,000, $12,500 in fact, right? 10 years, oh geez Louise, $19,000. 20 years, oh that's weird. Is that weird? 17,000? Is that weird or no? Oh no, because why? Oh, it's a parabola, it's starting to come back down, right? And then 25, $8,500. So after 5 years, who had the most? Carl, okay. After 10 years, who had the most? Carl, okay. 20 years? Still Carl, right? He's at 17,000. And then what about 25 years? Alan. Okay, so far? It's given that Carl had $1,000 after 28 years. How much do each of the other siblings have at this point? Well, how are we going to figure out how much Alan had after 28 years? what can we do with his equation? So I could say 1,000 plus 750 times what? 28, right? Well, what is 1,000 plus 750 times 8? Or times 28, excuse me. Exactly, right? $22,000. And then what about Bernice? How are we going to figure hers out? Sorry. So 1,000 times 1.12 to the 28, right? Is it okay that I didn't put 1 plus 0.12 and I actually did the math in my head? Are you okay with that? So 1,000 times 1.12 raised to the 28th power. $23,000. Okay, you ready? Let's use the graphs. And by also the graphs, I mean the calculator too, yes? Okay. I'm going to go back to my graph page, this page, and I'm going to get rid of my table. Okay. After approximately how many years did Alan and Bernice have the same amount of money? How am I going to figure that out by looking at the graph? Which one of these was Alan's again? The line, right? And which one's Bernice's? Exponential. So what am I looking for from those two lines? Where they cross, right? So I'm looking for where they cross. So I'm going to have to say menu. Let me zoom in again real quick. Menu, analyze. What am I going to choose? Intersection, good. And now it's asking for the two graphs that I want, right? I want the line, click, and I want the exponential growth, click. Then it gives me this dotted line, so I have to move the dotted line to the left of the intersection and the right of the intersection. Okay? So my graph says 27, 2.12E4. So let's make sure we can understand that. What does that mean? 27, and what does this mean? Times 10 to the 4th, so I need to move this decimal place 1, 2, 3, 4. So that's the number it means, right? So that's the point of intersection. Now let's answer the question. After approximately how many years did they have the same amount of money? So after 27 years, what is the amount? They both have, perfect, $21,200, right? Doesn't that one sentence answer both of those questions? Okay. After approximately how many years did Alan and Carl have the same amount of money? So what point am I looking for now? That one, right? Alan and Carl. So same steps that I went through in the first time. So menu, analyze, intersection. But this time I want the line and the parabola. Left and right. Now it's getting kind of messy because of all the things that I'm looking for, so I'm going to go and move that one so I can see it a little bit better. Okay. And what I see on my paper is, or on my graph, 20.5, 1.64 E4. Is that what yours says? Okay. So let's make sure we understand what number this is. 164 E4 times 10 to the fourth, so 1, 2, 3, 4, right? So now let's answer the question. After how many years did they have the same amount of money, and what was that amount? So after 20.5 years, because remember X is the time, right? The time. Then what? Good. Would you please circle number 7 and number 8? 7 and 8 are going to be 2 of your homework problems for tonight. Okay? And then would you please go ahead and get out your other worksheet? And please turn to problem number 3. You notice that what we're talking about today is nonlinear systems, right? Do you remember doing systems of equations? Yes, and most of the time your favorite way to solve a system of equations was the calculator, right? The problem with this is they're nonlinear, so I can't use a matrix to solve these systems. I have to use substitution or elimination or graphing, all right? So, but before I can actually solve the system, I have to have a system, right? I have to have a system written. So let's work on problem number 3. A rectangle has an area of 36 square units and a perimeter of 25 units. Find the dimensions. Well, it gives me 2 things I have to look for, right? Area and perimeter. Do you know how to find area? How do you find area of this? So x times y should equal what? 36. It tells you that in the sentence, doesn't it? Okay. And what about perimeter? Do you know how to find perimeter? You know how to find perimeter of this? How? So 2x plus 2y equals 25, right? Okay so far? Now, we're going to solve this system with substitution, so you can remember how to solve with substitution. Okay? Well, if we're solving by substitution, please remember that what we have to do first is solve for a variable. I have this variable, this variable, this variable, or this variable to choose from. Okay? If I solve for one of these variables, I'm going to divide by the other one to get one of the variables. If I solve for one of these variables, I'm going to end up dividing both sides by 2. Okay? So it doesn't matter which way we do it. No, it does not. Which way would you like to do it? Which variable would you like to solve for? Say it one more time. Okay, so which variable, x or y, do you want to solve for on the top one? Y. Okay, so for solving for y in the top equation, first I need to divide both sides by x, right? So y is going to equal 36 over x, right? Good. What do I do with that now? Where should I take this? I should substitute it in the other equation where y is, right? So 2x plus 2 times 36 over x equals 25. Good, right? Okay. 2x plus 72 over x equals 25. Can we have an x in the denominator when we're trying to solve? No? So how am I going to get the x out of the denominator? Multiply every single thing by x, right? Okay? If I multiply every single thing by x, I get 2x squared plus 72x. Oops, nope. Why is it not 72x? Yeah, x is simplified to 1, don't they? Equals 25x. Now, what type of problem has this just become? It is a quadratic, which means I should get it equal to 0. So let's subtract 25x from both sides. You okay with that? So 2x squared minus 25x plus 72 equals 0. Do you remember how to solve this? AC, right? We're factoring it with AC. So AC is 144 and B is negative 25. So I have to figure out what two numbers multiply to be 144 and add to be negative 25. Do you know what they are off the top of your head? Do you remember what to do if you don't know what they are off the top of your head? I just trying to write them down, right? 1 and 144, 2 and 72, 3 and 48. Still not getting negative 25, right? 4 and 36. Does 5 work? No, it doesn't divide into 144, right? 6 works though, 6 and 24. That's getting closer, but I still can't get 25, right? 7 doesn't work, 8 works. It's 8 and 18. Ooh, that's so close, but that's 24, right? 9 and 16. Ding, ding, ding. Right? So now I need to rewrite this problem. 2x squared minus 9x minus 16. Why do they both have to be minus? Perfect. I need negative 25. They need to add to be negative 25, right? Plus 72 equals 0. There's 4 terms, so I'm going to factor by grouping. What's common in the first 2 terms? Just an x, right? What's left to divide just an x out? 2x minus 9. What's common in the second 2 terms? Knowing that my parentheses needs to say 2x minus 9. An 8, right? In fact, a negative 8 is what I need to take out, isn't it? Then what I'm left with is a 2x minus 9. What do these 2 terms have in common? 2x minus 9. And what's left if I take out a 2x minus 9? X minus 8. Now these two, according to zero product property, what do I do with these two? So 2x minus 9 equals 0, and x minus 8 equals 0. So if I add 9 to both sides, I get 2x equals 9. And then dividing both sides by 2 gets me x equals 4.5. And then here, if I add 8 to both sides, x equals 8. Now think about what we're solving for just a second. This is a real world problem, like a real life problem. Could x be 4.5 and could x be 8? Could x be negative 4.5? Oh no, absolutely not, right? Because we're trying to find the dimensions of a rectangle. So if I got a negative here, that would be a problem, right? But x could be either one of these, couldn't they? Okay, so if x was 4.5, what is y? What's 36 divided by 4.5? So if x is 4.5, y is 8. What if x was 8? If x was 8, what is y? 4.5. That means if this is 4.5, this is 8. And if this is 8, then this is 4.5. Does that make sense? Any questions? Look at number 5, please. Well, while we're there, go ahead and circle number 4. Okay, circle number 4. and circle number 5. But while we're at number 5, there's 2 equations you're going to need to know for this. Okay? You're going to probably need, let's see, what kind of equations do you think you might need to know for a triangle? Maybe this one? Yep. And then there's a sentence right here. The hypotenuse is only 3 centimeters long than the other leg. That's where you get the second equation. Okay? But please also circle, besides 4 and 5, please circle 10 and 12. 10 and 12. Okay? So you have 4, 5, 10, and 12 on this page, and then you have 7 and 8 on this page. Got it? Any questions?